This is an AP calculus problem involving average rate of change and trapezoidal sums. So we're going to analyze this. The table shows the depth of water W in a river um, as measured at 4-hour intervals during a day-long flood. Assume that W is a differentiable function of time, t. So this preamble to the table is really important because that gives us confidence that we can do certain things that otherwise we wouldn't be able to do. And so part A, find the approximate value of W prime of 16, indicate units of measure. For the uninitiated, you might be tempted to say, well, W prime of 16, we just read off the graph, so that's obviously 35. But no, W prime is the rate of change. And so to do that, we're going to need to find values, the rate of change. And what I like to do is take either end. If 16 is included in this case, we'll use 12 and 14. So our average rate of change, so W prime of 16 equals our average rate of change, and that's going to be equal to W of 20. So what's going to be the depth of 20 minus the depth at time equals 12 hours. And that's going to be over, you have, in this case, 20 minus 12. And that's going to be, let's see, 33 minus 37 over 8, or you just leave it 20 minus 12, we might call it 8, and it's going to be, the units are going to be feet per hour. And if you work this out and simplify, you're going to get -1/2 feet per hour, but it is not necessary to simplify beyond this. And don't box in your answers. So you have a correct answer here. You can only make an arithmetic mistake and blow your correct answer. Estimate the average depth of water in feet over the time interval from 0 to 24 hours by using a trapezoidal approximation with subintervals of length delta t equals 4 days. Well, really, there's a little mistake there, isn't it? It's going to be 4 hours because the units are in hours. But that little inaccuracy besides, we're going to have the estimate, put EST, of average depth. It's going to be an average value. So we have 1 over B minus A, so that's going to be all 24 hours, so it'll be 24 minus 0 times the trapezoidal sum. Now, you're going to have 6 intervals, 1, 2, 3, 4, 5, 6. So I'm going to go ahead and just put 6 blanks separated by plus signs, and running out of room, I'm going to go ahead and put 3 more down here below. Okay, and then for that, we divide every one by 2, because that's part of the trapezoid formula, 1/2 h times quantity base 1 plus base 2. And our width is going to be 4 for each of these. And then we have this base 1 plus base 2, so that's going to be 32 plus 36. Our next one's going to be 36 plus 38. Our next one's going to be 38 plus 37. Then we have 37 plus, what was that next one, 35? Not tremendously legible. Then we have 35 plus 33. And then finally we have 33 plus 32. And then the units, which will simply be feet. And says, does it say any other interpretation besides that? No, that's it. So we don't have to go any further. Part C, scientists studying the flooding believe they can model the depth of water, which the function, with the function f of t equals 35 minus 3 cosine quantity t plus 3 over 4, where f of t represents the depth of the water. So we can go in and put this in our calculator, but before doing that, I'm just going to set up part C below. And I guess I'm going to go ahead and go to the left here at this point. So f prime of 16 equals we'll say d dt, derivative with respect to time, of 35 minus 3 cosine, we have t plus 3 over 4, and we evaluate that, put a little vertical line for t equals 16. And we can go to our, in this case I have a TI Nspire CX calculator, and to be able to get a derivative point, we can press Control and then the minus sign, except that's not it. It's Shift and the minus sign. And we're going to put ddx here, and we're going to put 35 minus, we have open parentheses, excuse me, that's not right, minus 3 times cosine of, now we have this here, we have x plus 3 over 4, and then we come out here and we're going to evaluate that. Now for the evaluation, we can press this, we press Control and then the equal sign right below it. We get this little vertical segment here, and we're going to put x equals 16. The one thing that's key before I press the button here is we have to make sure our calculator is in radians. You see the upper right, we have RAD, and then when we go over the symbol, the radian pops up. So everything should be good here, and we press Enter. We get negative 0.749 rounded to the nearest third decimal place. So we put equals negative 0.749, and we put our feet per hour, and it says explain the meaning of your answer in appropriate units. So you can say at t equals 16, the water level is, I'll put it down here, is falling or receding. I'm going to put receding at a rate of negative 0.749 of, not negative 0.749, a rate of 7.749 feet per hour. Now I just about made a mistake. When you say receding, the word receding or falling or declining is going to include the negative sign. So if I say receding at a rate of negative 0.749 feet per hour, that would cost me a point. Last part here, part D. Use the function f to find the average depth of water in feet over the time interval from 0 to 24 hours. So average depth is equal to same as for this earlier with part B. We have 1 over 24 minus 0 of the integral from 0 to 24 of the same function. We have 35 minus 3 cosine t plus 3 over 4 dt. So we can go in our calculator again, and this time to get an integral, if you press, first we're going to do the fraction, so we're going to take 1 over 24, and then now to get the integral we can press shift and then the plus sign, and we're going to go from t equals 0 all the way up to 24, and then we put in the function here, and I think we can just put it in like this. We put in 35 minus 3 cosine, and now the parentheses, so we get a fraction there. We'll put in x plus 3 over 4, and then finally over here dx. We should get around 35 feet somehow. Yeah, 35.116 out of the third decimal place. 33.116. And this will be feet. Now, if you don't round at all, you can take the first 3 decimal places as they appear. So 35.1 1.5, and you put 5.8, it wouldn't matter. I do want to tell you that for part A, instead of using W of 20 and W of 12, we could have used W of 20 and W of 16, or W of 16 and W of 12. So if the number in itself is there, that also can be used. So this is one of 3 possible right answers for part A. Anyway, good luck. Problems like these are good preparation for your AP test coming up. Thanks for viewing.